Hello viewers, welcome to the section Concurrency in C++. In this section we will learn about writing a simple Hello World program and concurrency tasks. Now we move on to the video Writing a simple Hello World program. In this video we will define a Hello World program using concurrency. Also we will see the asynchronous message passing using the concurrency support library. Every modern programming language supports concurrency, offering high-level APIs that allow the execution of many tasks simultaneously. C++ supports concurrency, starting from C++11, and more sophisticated APIs got added further in C++14 and C++17. Concurrency lets us execute independent tasks. Even loop iterations can run concurrently without writing complex code. The bottom line is parallelization, which is made easier with concurrency. The concurrency support library complements the C++ thread support library. The combined use of these two powerful libraries make concurrent programming easier in C++. Open the Atom editor. I have already imported the ex1 file where the Hello program was written. Let's define a simple Hello World program using C++ concurrency in this main.cpp file. Let's try to understand the main function. Future is an object of the concurrency module that helps the caller function retrieve the message passed by the thread in an asynchronous fashion. The void in future represents the sayHello thread function that is not expected to pass any message to the caller, that is, the main thread function. The asynchronous class lets us execute a function in two modes, namely launch asynchronous or launch deferred mode. The launch asynchronous mode lets the asynchronous object launch the sayHello method in a separate thread, whereas the launch deferred mode lets the asynchronous object invoke the sayHello function without creating a separate thread. In launch deferred mode, the sayHello method invocation will be different until the caller thread invokes the future get method. The future object wait voice is used to block the main thread to let the sayHello function complete its task. The future wait function is similar to thread join in the thread support library. Let's go ahead and compile the program. Go to the terminal and type G++ with the file name that is main.cpp and the output file name concurrency. As you can see, our program is successfully compiled. Let's execute our program using the command /concurrency. We have obtained a simple print statement. Next, we will see the asynchronous message passing using the concurrency support library. Go back to our Atom editor and click on the ex2 folder and open the main.cpp file. Now close the main.cpp of the ex1 directory. We will slightly modify main.cpp of the Hello World program which we wrote previously. Let's understand how we could pass a message from a thread function to the caller function asynchronously. In the previous program, promise object is used by the sayHello thread function to pass the message to the main thread asynchronously. Note that promise string implies that the sayHello function is expected to pass a string message, hence the main thread retrieves future string. The future get function call will be blocked until the sayHello thread function calls the promise set value method. However, it is important to understand that future get must only be called once as the corresponding promise object will be destructed after the call to the future get method invocation. Did you notice the use of the move function? The move function basically transfers the ownership of promise object to the sayHello thread function. Hence, promise object must not be accessed from the main thread after move function is invoked. Let's go ahead and compile the program. Go to the terminal and navigate to our ex2. Then clear this screen using the reset command. Type the command G++ with the file names. As you can see, we have successfully compiled our program. Now, run the program using /concurrency. Observe how the concurrency application works by launching it. As you may have guessed, the output of this program is exactly the same as our previous version, but this version of our program makes use of promise and future objects, unlike the previous version that doesn't support message passing. In this video, we learned to write a simple Hello World program.